So now let's get on with this. Please solve this numerical, all of you. आराम से, आराम से solve. Just you enjoy solving this. Don't put any pressure on yourself. Whatever you have learned, you put it to you. This one. Sarthak, if you cannot see, you sit here. Is only one partition surface at an instant when it is parallel to x-axis. So you see this rod is on a table. Right? This rod is on a table. Right? What you are seeing is the rod is there and you are seeing it from the on top of the table. And there are two velocity vectors. And etc. etc. Find the angular velocity and velocity of its center. So, and obviously they said locate its instantaneous axis of rotation. This means center means the center of mass. Velocity and velocity of its center. Center means center of the rod. It's a uniform rod. So center of the rod is the center. That's right. It is different. Center of mass is different. Instantaneous axis of rotation is different. Obviously. Anybody has found the answer? You can tell me. Aram sir, no hurry. Somebody has got, just say you got the answer. Got
velocity. Yes, run. One more time. Done.
Yeah. Others also take some time, another 2 minutes. See, from whatever you have learned, you have to apply it here. That's it. That the rod is given like this, and this is 30 and this is 20. Am I right?
Yes, sir.
And they have told the rod is 100 centimeters.
Yeah.
Okay. Now, from the theory that you have learned, okay, you can do it by many means. So I would prefer to join this like this. So you have already learned, and this is a simple abstraction. So this becomes what? The point axis of rotation, instantaneous axis of rotation. So you can give some name to this.
Instantaneous center.
So instantaneous center. So Okay, instantaneous center. I see you will be name to this. Okay, and this is 20 and this is 30. So this is one thing. So if you take the similar triangles here, then you will get to know what is where is this point located. Okay, here is this point located, and you can see here this is in the ratio 2:3. Therefore, this 100 will also be in the ratio of 2:3.
40.
So it should be 40 and 60.
Yes, sir.
40 and 60. So this has to be 40 and this has to be 60. See, you should be able to intuitively solve it like this. So you have located the instantaneous center. Okay. Then you see, with respect to this is moving with omega, and with respect to the same point, this is also moving with omega. Isn't it? So therefore, omega into 60 must be equal to 30. Therefore, omega must be equal to 0.5 radians per second. Okay, and this is located here.
Yes, sir.
Quite simple, right? Huh?
Yes.
No, how further? So, see, this is a very simple sum. You should be able to tackle it like this. I hope everybody understood this.
So you only have to
Yes,
find the
sir.
velocity
Yes,
of
sir.
the center.
Yes.
What else have they asked?
Velocity of center.
Yes, it's correct. Velocity of the center. They have asked the velocity of the
It will
center.
be at 15.
Okay. So,
10
what will be the velocity of the center?
5 centimeters.
How did you find out?
Sir, it will be exactly at the middle, sir. Uniformly distributed, sir. Rod is uniform.
Rod is uniform.
So it will be at 50 centimeters, sir. Center of mass.
Center of mass is at 50 centimeters. This is 40. This should be 50.
Velocity is
This
omega.
is center of mass.
So velocity is omega into r, sir.
Hmm.
And omega is half into 10. It will give us 5 centimeters per second. Velocity of the center.
Once again, make it clear to everyone.
Sir, like the side, because it's a uniform rod, so the center will be located exactly at the middle, so it will be 50 centimeter. And from the instantaneous axis of rotation, it's at a distance of 10 centimeter.
Okay.
So now omega is half, and
So
the
you
distance
took this as 10, this is 10 centimeters from here.
So
Omega is same,
is, sir.
right? So omega into 10.
We get 5 centimeter per second.
Yes.
That's the velocity of the center.
So the velocity of the center EC will be equal to omega into 10 centimeters. So just now you found out omega to be half, and this is into 10, you will be able to get 5 meters
5
per
centimeters.
5 centimeters per second. Well done. Okay?
Yes.
So this is how everything gets organized. Has anybody tried any other method of solving this? Anybody? Okay, because I was thinking that we just now solved the radar problem like this.
Yes, sir.
So we said, well, this is A and B, and then momentarily we took A as at rest, and we did that. So you can do it like that also here. That is relative velocity
Relative
concept.
velocity concept, yes, sir.
So you can use relative velocity concept also. That is, now you silence this point A. Okay, silence this point A. How will you silence it? You will add a vector 20 up to this. Therefore, if you say this point A is notionally at rest, then this B will be 50.
Yes, sir.
Okay, hello?
Yes, sir.
50 meters per second, right? And this A is 100. Okay, then this whole rod is rotating with same omega. Okay, I have only changed this point A. So again you see here, omega into 100. Okay, 100 is, I have taken it in, this is meters, no? So let me take it, omega into 0.1.
So that is
Okay.
centimeters of 50
This
centimeters.
was centimeters only, yeah. Okay. Centimeters per second. So therefore, omega into 100 will be equal to 50. So again, you get omega is equal to 0.5. Okay, radians per second. You can do it like this also.
Yes.
Okay? So you can attack this problem in different ways, right? So you can see all your kinematics, relative velocity and this, that, and all will be used here. Fine. I'll go on to the next problem, students.
Yes, sir. Point out, sir.
Yes,
Sir, here if the rod was rotating about its center of mass, sir, and such that the A and T has velocity 25 meters per second.
Okay, you want to make a problem like that, huh?
Sir, means that is also a possibility. No?
No, what you are telling, the rod is rotating about its
Center of mass.
Okay.
Such that the tips of the velocity 25 meter per second.
This is a new problem there.
And now translating upwards at 5 meter per second, sir, you get the same condition also.
This is moving at 5 meters per second. No, yes, fantastic. Very good.
So how do we differentiate?
How do you differentiate is, you see, now here, see this 25 centimeters per second, and this is also 25 centimeters per second. So this has got this component in this. This has got this component, isn't it? Hello?
Sir, no, sir, will not consider.
Sir, this condition is reverse of that.
Initially it was rotating, sir, now it has started translating.
Initially it was rotating.
Now it has started translating, so it will be 25 plus 5, 25 minus 5.
Exactly.
Okay, sir, okay, sir, okay, sir, okay, sir.
See, you after getting this answer, you have put it like this.
This is
Yes, sir.
Okay, that is what you are telling is before you have just split this into two. What I would like to say is, you are looking at it like this. So one is this rod is making only pure rotation. Okay, pure rotation, and the rod is having pure translation. Okay, so it is pure rotation means this is 25 centimeters per second, this is 25 centimeters per second, and this is moving with velocity vc is equal to 5 centimeters per second. Okay, so this is pure translation and this is pure rotation. So combination of these two will give you the current condition of the rod.
Yes, same thing.
Okay. Why reverse? When you are told this is 30 and this is 20, why are you telling reverse?
Sir, that when you apply again that relative velocity concept, no sir, the top one will become 20 and the bottom one will become 30.
Why are you? What does this mean?
No.
If you add this to this, you are going to add VC here, you are going to add VC here. And what is sir? Okay, fine. Well, good abstraction. Okay, so you can see this in many ways, and you can comprehend. And these are all illustrated sums, so it's all meant to let's understand the concepts and skills that are presented. All right, so we'll go on to the next numerical. So you want to see the solution given by the author? Well,
Yeah.
no, I am not there. These are all questions asked in many of the examinations which I have just studied. So, so the same thing. We have written the equation here. VB bar is equal to VA bar plus omega AB bar. Same thing. What we have done intuitively, but he has done it very methodically by writing these equations. AB, AC. Okay. And of course, this as far as finding the center is concerned, is the same methodology. Okay. And here, analytical method, the instantaneous is at rest using this. Yes, again, this is something which we have used. Clear?
Yes.
Nothing, we have already done this. Let's go to, this is again relative velocity concept.
Yes.
So we have done all the things. Now this one is quite interesting numerical. A 50 centimeter long. I think all of you can read this.
Yes.
Please solve it. I will also solve on a table. So they are given the net velocities. That's what you have to see here. They are given the net velocities at point B and point A. Aram se, net velocity is what they have given. That means whatever velocity they have given there, VAY and VBX, and they have named it as VBX and VAY. Okay, that means both of them are perpendicular to each other. That means it is the summation of two components. Sorry, once again, I am sorry. At an instant, the velocity component of point A
Yes.
perpendicular to the rod. They have made it very clear. It is the component of velocity they have given there. And the velocity component of B parallel to the rod. I suppose you can read this. That means there is some other velocity, only these components are given. Horizontal. That means you have to presume there is a vertical component at B and there is a horizontal component at A.
Yes.
And attack the problem. Find the velocities of vectors A and B. And angular velocity they have given. It's a nice problem.
Yes, sir.
Very nice problem. Sorry. You can see so much of happiness in Dimant and Arun. Sorry, you comprehend the problem quickly, man.
Yes, sir.
See, your mind's eye should work like this. Listen,
Yes,
Arun, see, I'll tell you. You should not look at the numericals. Your mind side, this rod is given, this component is given, this component is given. And angular velocity is given. Okay, and they have given the length of the rod. See, your mind should capture this quickly. Okay,
Yes,
that's
yes.
it. And they are giving the and angular velocity is given.
Yes.
Okay, and find the velocity vectors, find the absolute velocity vectors
Yes.
at A and B, like at the instant is over.
Yes.
Then you should not see the board.
Why?
That's it. Just you comprehend like this. See, you are concentrating on the numericals. I mean the numerical values. So that is not the way to handle the problem. And numerical values, you just have to plug in. You get the strategy right. So I will also enjoy solving with you. So they have given this and they have given this. So therefore, I will have to assume this. understand the rigid body diagram. This is, sorry, this is rigid body dynamics. So there are some things which are unique here. And 10.
Yes.
Okay, friends, I think it's quite a bit of time. Hello?
Yes. Yes, sir.
Yeah. So as you can see in this numerical, they have given a rod and they have given these two velocity components. And they said these are the components of velocity at the time, horizontal and vertical component. Okay. Now, and since this is a rigid rod, Okay, this is a rigid rod. This is a rigid rod. Therefore, this component of A, that is VAX, and this is VBX. They must be equal. Okay, because in a rigid rod, it cannot have relative velocity. This point and this point cannot have relative velocity, so I wrote this, and this is equal to 6 centimeters per second. So I found out VAX directly by inspection.
Yes, sir.
Yes, sir.
See, in a rigid body, the 2 points are fixed.
Yes, sir.
They cannot have relative velocity. See, this velocity and this velocity cannot be different.
Okay, sir.
I mean, the velocity component along the direction cannot be different.
Sir, but how, like, you to get as positive extraction?
I see this point and this point, this component and this component cannot be different. If they are different, then A and B will start moving away.
Ah, okay.
Yeah.
I see.
So therefore, directly from inspection you can get it.
Yes, sir. Yes, sir.
Right. And they are given L and they have given omega. They are given L and they have given omega.
Yes, sir.
Okay. So now what I will do, I will use the concept of relative velocity. Okay. So I will add this to this. Okay. That is, I will notionally stop this. So if I notionally stop this, then the Vx component will get vanished. Okay. And this point will be at rest. And this component will get added up to this. So this component, relative velocity, Vby plus Vai will be the total component in this range.
Yes, sir.
And that must be equal to omega into L. Omega and L are given. So Vby will be equal to omega L minus Vai. So omega is 0.4, this is 50, and minus 10 you get 10 centimeters. So we found Vby. So Vby, Vai are 10, and Vbx and Vax are also same. So therefore, this will be 6 square plus 2 square root of this, because the angle is 90 degrees. So you get this as root of 136 Vb. Got it?
Yes, yes.
Of course, you have to write it in vector form and all that. Let us keep it like that. Okay. Now regarding the instantaneous axis of rotation. Okay. So now what I do, I will add these two components. This component and this component. If I add, then this will be the result.
Yes, sir.
And similarly, this component in this component, if I add, this will be the result. So IAR will be what? I will draw a perpendicular to this axis and I will draw a perpendicular to this axis. Okay. So this point will be the IAR. So this will have two components, X and Y components. This should have X and Y components. Correct?
Yes.
And you have to find out IAR from this. So whatever you want to use, you can use. You can use the geometry or you can use the vectors and you can determine that component.
Yes, sir.
Got it?
Yes. Yes.
Okay. So now, supposing it had only the Y component, then if it had only Y component, then both the Y components are equal. So the X component of this will obviously be 25 centimeters.
Yes, sir.
X component of the IAR will be 25 centimeters.
Yes, sir.
Got it? Now coming to the Y component. Coming to the Y component of this. Okay. So where will be the Y component of this? Because now you know this proximity. This proximity is what you have to see. Right? So now that you have located this to be 25 centimeters. Okay. And then you have to locate the Y component of that.
Sir, it will be, sir, like that angle which is between the triangles, sir, like the axis of instantaneous axis of rotation, that radius and that 50 centimeters.
Yes,
That
yes.
will be 45 degrees.
Why will it be 45? No, it will not be 45.
Sir, 1 minute, sir. Like when we use their angle, no, sir, like that angle which is made by VB, that total resultant angle, sir. There, if you will take that perpendicular component and when you use tan theta, sir, you will get it as 10 by 6.
No. See,
No,
see,
sir,
this,
no.
see this angle you can find out.
That
This angle you can find out. Okay, this angle you can find out. If you find out this angle, then you can find out this angle. And this angle will be 90 minus this angle.
Yes, sir.
Yes, sir.
And by the afternoon.
Correct. So this angle will be equal to this angle.
Yes, sir.
This angle will be equal to this angle.
Yes, yes, yes.
Okay, and since you have found out this to be 25, so tan of this angle will give you this divided by 25.
Yes.
Yes.
Correct? Okay,
Yes.
so it will give you that. So you'll be able to find out. Did you all get it, students?
Yes, sir.
Yes.
See again here you see, addition of vectors, then a relative velocity concept, okay, etc. Everything is being used here, and then simple formulations. So this illustration very clearly demonstrates, all that we have learned. Instantaneous axis of rotation, how to find out perpendiculars drawn here, etc., etc. Everything is
Yes.
connected, and you get this.
Yes, sir.
Lovely problem. Right? Okay, shall I go to the next one?
Yes, sir.
Yes.
Everybody there?
Yes, sir.
Yes. Yes.
Huh. Yeah, you would like to see their solutions of the author? Definitely would like to see. Why you would like to see? You got the answer?
Different approach.
Yes, different approach. That's a good one. Yeah. So the first approach, what we have done. No, don't go on reading everything. The first approach we have got is this. The second approach is, well, I think this is better. This is also a good way of doing. So it is written in the vectorized form. So V bar is written, V A bar is written, omega bar is written. Omega bar you see 0.4 K bar. Right? So K bar is coming out, and into AB bar, okay, is written here. So 50I. So equating and all, we get this. And then from one end to VA bar is equal to so and so, VB bar is equal to so and so. We get the two. So we got the same thing, right? So root of 100 square plus 6 square, 136 root 136 square. Right. But this is the right way to write, because I told you have to write in the directions, and this one you have to write. Okay. Instantaneous axis of rotation. So instantaneous axis of rotation, Vp bar. Okay, that is velocity at the instantaneous Vp bar. You remember P is taken. Va bar omega AP bar. Hello.
Yes, sir.
Yes.
Right? I suppose you got this one here. So you see here, that is A is taken to be at rest.
Yes.
Point A is taken as rest, and P bar is calculated here. And here you see the instantaneous axis of rotation. So P is at rest. So therefore we wrote it as 0 bar. Right? Then A bar, so and so, because instantaneous axis of rotation, then equating the coefficients, you directly V bar. X is equal to 25, Y is equal to 50.
Why out?
We did by equating the components you are getting. What we did was, we took the angles and we did.
Yes, sir.
So by that also we should get 15 centimeters.
Yes, sir.
You want to try it out?
Yes, sir.
Same angle. It's correct, You got it? By angle? The angle you got this. What will be this angle? This angle will be what? Tan theta of this will be what? This 6 by 10.
Yes, sir.
So, supposing I take this as theta, so it will be tan theta will be equal to 6 by 10.
We'll get
Okay, and this is also same, 6 by 10. So this will be some height y. Okay, some height y by 25.
so it will be 10 by 6.
25, so y will be 15.
Okay, so therefore y will be equal to 25 by into 6 by 10. So here 5 is a 5 2 is a 2 is a 2 3. So 3 by 50. We got y 15 centimeters. Okay, but this is a better way. You
Yes,
go by vectors, you will find it much easier.
Sir, there's another axis, sir. There is, sir, on the top one, sir. At point B, sir, when we find tan theta, sir. No, sir, at point B, sir. There's, sir, like when we take opposite, it will be 10, sir. Then adjacent.
Wait. You want to take this one?
Not the
This angle.
The angle between the final resultant and the VBX.
VBX, this one.
This one, theta.
Huh.
When we'll take that, it will be.
What we get? You will get here. See, then if you do that, then you will get this angle, and then you have to take tan of 90 minus theta.
90 minus, yeah, they will get
90
yours.
minus theta. So you should not take this. This angle will be equal to this angle.
Yes, yes.
Sorry, this angle will be equal to this angle,
This one, yes, sir.
and this angle will be 90 minus this angle.
Okay.
Right? Fine.